So after my students complete the dropping the ball lab, students will return to their groups and complete the report. Here I will be asking the questions above to guide students into the conservation of energy portion of the lessons. They will have to deal with systems and energy. I will be asking them, what is a system? What forms of energy can be found in this system? And then remind them the system is uh, the setup that we made in the lab. And then for energy, how do energy and systems relate with one another? What law can we think of that relates these together? And what variables changed in the system which stayed the same? I would then have the students alter their data and convert their findings into values of potential energy and kinetic energy. I would then ask the students the questions found above. What variables do we need to calculate potential energy? How do these variables relate to one another? What kind of relationship does potential energy have with the height? What does this graph look like? Then concerning kinetic energy, what variables do we need to calculate kinetic energy? How do these variables relate to one another? And what kind of relationship does kinetic energy have with velocity? What does this graph look like? Students then would return to their already accumulated data and would calculate kinetic energy and potential energy and then graph this. Above is an example of the authentic data that I collected from the Go Motion sensor. The students would use this data to graph the relationships between kinetic energy and potential energy and also show how this relates to the total energy of the system and then make conclusions. After students altered their data, I would ask them to relate their findings to the real world. Once they came up with their own examples, I would show them mine. My example is a roller coaster. So the link would open this simulation here, and I would play this for them. And this shows the relationship of kinetic to potential energy in the system. So after showing the simulation, I would then ask the students, when was potential energy at its max, when was kinetic energy at its max, and how does this relate to the conservation of energy equation? I would then confirm what the students have already deducted from the last slide of the questions, that potential energy is highest and at its max at the maximum height, and there is zero kinetic energy. Then maximum kinetic energy is when the height is at its lowest, and then somewhere in the middle where you can see they're going up a smaller hill. I would then cover how calculations and equations fit into this law using a ball being dropped as an example so the students could apply the knowledge to the lab. I would then show how the calculated kinetic energy and potential energy looks at each point during another real world example. Here there is a skier, and the skier is at the top of the hill, going down the hill, going off a jump, and then at the end here. So the students would then be asked the following questions concerning the last real world example. How did the potential energy and kinetic energy compare at the top of the hill? How about at the bottom? During the jump? Did the total energy differ at any point? What does this tell us about the law of conservation of energy? After going through the short inquiry-based lesson, I would then introduce the new project where the students would incorporate everything they have learned up to this point, and they would end up building a marble run with at least one loop in it. They would apply what they learned to develop a successful run where the marble travels through the entire loop, and the entire track. And I would also ask a question to keep in mind what would aid in complete travel through the loop.